Hi, everyone. My name is Marina Komaroff, and I'm Senior Director of Biostatistics and Product Development Team in Noven Pharmaceutical. And today I'm going to talk about d-Amphetamine Transdermal System in treatment of children and adolescents with ADHD, secondary endpoint results, and post-hoc effect size analysis from a pivotal trial. I want to start with introduction, then I will review pivotal study design, concentrate on objectives and post-hoc analysis, share the results, summarize safety, and finish with conclusions. Amphetamines are a preferred treatment for ADHD. Dextroamphetamine transdermal system, d-ATS, is an alternative to extended-release oral amphetamine formulations for ADHD. d-ATS patch offers advantages over oral formulations. It's easier treatment for children who have difficulty swallowing oral medications. Also give us fewer GI effects, gives us flexibility in treatment duration, and visual confirmation of adherence to the treatment. d-ATS was approved by FDA in March 2022. It is indicated for treatment of ADHD for adults and children 6 and greater years of age. A pivotal trial of d-ATS in children and adolescents with ADHD met primary and secondary objectives. In this presentation, I will report additional safety endpoints findings from the pivotal trial and include results from post-hoc analysis that evaluates effect sizes and numbers needed to treat. A pivotal trial was a randomized, double-blind, placebo-controlled, crossover laboratory classroom study to evaluate safety and efficacy of d-ATS compared to placebo in children and adolescents with ADHD. It included two periods, dose optimization period and double-blind period. Let me show you the schema of the pivotal trial. Study started with screening that lasted about 4 weeks. Then participants went through washout 3 days. Next, they came for the baseline visit, after which participant started dose optimization phase that lasted 5 weeks, week 1 through week 5, after which subjects were randomized into double-blind period, which was crossover part of the study. Subjects started d-ATS or placebo and switched in the second part of double-blind period. This part lasted 2 weeks. In dose optimization period, subjects started with 5 milligrams, and then they went through evaluation, after which they had a chance to increase the dose, and increase went only by 5 milligrams. If subjects, after evaluation, if subjects satisfied this optimization criteria, increase criteria, they next week they increased the dose to 10, after which to 15, and maximum dose was 20 milligrams. Once subjects reached optimal dose, they kept it for the remaining time frame and also were randomized with this optimal dose to double-blind period. In double-blind period, it's crossover. Subject kept optimal dose or placebo, and then in week 7, they switched. Overall population who enrolled in the study was mostly children, 73%, and 27 were adolescents. Average age was 10.5 years old, mostly males, 69%, with body mass index 18.7, and the baseline for ADHD RS4 was 38.3. After dose optimization phase, we can see that majority of subjects, 33% and 39%, had 10 milligram dose and 15 milligram dose, respectively. Only 7% of subjects had 5 milligram as optimal dose, and 21% had maximum dose, 20 milligrams. This pivotal study has primary objective to assess efficacy and safety of d-ATS. The primary endpoint was SCAMP total score. Key secondary endpoint was onset and duration assessed by SCAM total score. Secondary endpoints included PERMP, ADHD-RS4, Connor's Parent Rating Scale, revised short form, and Clinical Global Impression Scale, CGI. Safety was assessed by adverse events, suicidality, ECGs, vital signs, labs, and assessment of dermal safety. All primary and secondary endpoints were met in the pivotal study. And now I will concentrate on 3 secondary endpoints and also include analysis from pivotal study with additional calculation from post-hoc analysis. The first secondary endpoint is ADHD-RS4 total score and subscales for overall population and by age group. Post-hoc analysis calculated effect sizes and numbers needed to treat for each subgroups. Second secondary endpoint, Connor's Parent Rating Scale. And the third one is Clinical Global Impression Improvement, enhanced with results from post-hoc analysis that calculated numbers needed to treat. ADHD-RS4 is a clinician-rated scale, and it was based on DSM-4 TR criteria. It consists of 18 items, where each item is scored from the range of 0 to 3. 0, no symptoms, 3, severe symptoms. So the minimal score can be 0, total score can be 0, and the maximum 54. The 18 items were grouped into 2 subscales. First, hyperactivity impulsivity included even number of items, numbered from 2 to 18, and inattentiveness, odd number of items, numbered from 1 to 17. Here, how form looks like. It was completed by mother, father, guardian, or grandparents, 18 items, and each of these items should be scored from 0 to 3. Here is the results for ADHD-RS4 total score by visit. As you can see, the baseline is close to 40. As I already mentioned, it was 38.3. Now green line represents the ATS and black dots placebo. As you can see, visit 1 through 5 dose optimization period. Blue line consistently goes down. It means there is improvement in ADHD RS4 total score by each visit. 6 and 7 is double-blind period, and we can see that placebo in that black dot and blue is d-ATS. We see statistically significant separation between d-ATS and placebo in favor of d-ATS as marked by 3 stars. Here are the numbers, and the difference between the ADHD total score is 13.1. For subscales in attention and hyperactivity impulsivity scales, we also see the statistically significant separation between d-ATS and placebo as marked by 3 stars. Effect size calculation was added as post-hoc analysis. All of them are close to 1. The minimum was 0.9, the maximum 1.2, which means there is a large effect size for each subscale based on cognitive classification. Next slide shows you separation by age group, children and adolescents. As we can see, the difference between d-ATS and placebo was statistically significant for each subgroup in favor of d-ATS. Effect sizes lasted also ranged from 0.7 for hyperactivity impulsivity subscale for adolescents, and the maximum was 1.2. Also, large effect size for each subgroup. Here we can also observe that for children, hyperactivity impulsivity was 1, and for adolescents it was the minimum, 0.7. And this is what was observed also from other longitudinal study, and I cited them in the bottom. And this was explained like hyperactivity and impulsivity tend to diminish when children grow to adolescence age. Here is responder analysis for ADHD RS4 score in double-blind period. It was analyzed 3 ways: remission responders. If we see 30% or above reduction from baseline, and also if we see 50% or above reduction from baseline responders. All of them demonstrated statistically significant difference between d-ATS and placebo in favor of d-ATS. Number needed to treat were added after post-hoc analysis, and it was equal to 3, which means only 3 patients needed to be treated with d-ATS instead of placebo to observe 1 additional patient achieving a clinically meaningful change. And here's a summary for all analysis for ADHD RS4. As I said, dose optimization demonstrated consistent improvement. Effect sizes were large for each analyzed subgroups, and number needed to treat were equal to 3. Second endpoint is CPRS short form. It's a standard instrument for the assessment of ADHD in children and adolescents and evaluates problem behavior. It is reported by parent or alternative caregivers. It contains of 27 items that should be answered in 4-level scale: 0, never, and 3, very often. And here the form looks like. Parent ID is in the top, and also we can see 27 items, and the answers go from 0 up to 3. The results of CPRS total scores you can see in the figure. In the dose optimization phase, we see also consistent reduction in CPRS total score. And in double-blind period, we see statistically significant separation between d-ATS and placebo in favor of d-ATS. This is a number. The difference, Ellis mean difference between d-ATS and placebo was 16.1 score, and it was statistically significant. The third endpoint is Clinical Global Impression Improvement Scale. It's assessed the subject's improvement relative to the symptoms prior to dosing. It was assessed by investigator. CGI scale starts with 1, very much improved, and goes to 7, very much worse. Here is the results for CGI responders. Responders here included 2 categories, 1 and 2, very much improved, much improved. Blue bars represent percentage of responders, and we can see from 1 to 5 dose optimization period, and we see how bar grow consistently from 1 to 5. In double blind, there is statistically significant separation between d-ATS and placebo in favor of d-ATS and marked by 3 stars. This slide presents 2 ways of responder analysis. In green, we can see if responder was defined less conservative. It included 1, 2, and 3 categories: very much improved, and minimally improved. And purple is conservative approach that we saw in the previous figure: very much improved and much improved. Both analyses demonstrate statistically significant difference between d-ATS and placebo in favor of d-ATS. Numbers needed to treat were added as post-hoc analysis for the most conservative approach, where it included very much improved and much improved categories. Only 2 patients needed to be treated with d-ATS instead of placebo to observe 1 additional patient experiencing very much improved or much improved ADHD symptoms as measured by CGI scores. General safety summary is presented here, and we can see that most of treatment-emergent adverse events were mild or moderate. Only 3 severe treatment-emergent adverse events in dose optimization and 3 during double-blind period. Only 3 subjects discontinued from the dose optimization period. and they were abdominal pain, irritability, and appetite loss. None of the subjects discontinued from double-blind phase, and none of the subjects discontinued due to dermal reactions in any period. There was no death in the study. Now I can conclude. In laboratory school setting, school-aged children and adolescents with ADHD receiving d-ATS demonstrated statistically significant improvement relative to placebo in ADHD symptoms measured by 3 endpoints: ADHD RS4 total score, CPRS, and CGI-A. In post-hoc analysis, we also demonstrated that d-ATS was efficacious and with efficacy comparable to oral formulation based on the large effect sizes and similar numbers needed to treat. Thus, d-ATS is important innovation, invaluable treatment option for patients with ADHD. And I want to comment that it's now available nationwide in all pharmacies across the United States. And now I want to thank everyone to listening this presentation. And here's my contact number in case if you have any questions. Thank you and goodbye.